Welcome to another Show Me with Mr. Oliver. We're looking at the distributive law, which is really chunking for multiplication and division. Let's look at a first example. 4 times 5 equals 20. You can see that 2 times 5 would give you the answer 10, and another 2 times 5 will be another 10. So 4 times 5 equals 20. How does this work? Well, 4 is how much you have, 5 is how many times you make 4, and the 20 in the answer is how much you have altogether. So it's really understanding the muchness and the manyness involved with multiplication and division. We can see here with my workings that 2 times 5 equals 10, and another 2 times 5 is another 10, to give you 4 times 5, which is 20. Let's look at another example. 5 times 6. What we're looking here at is the number 5, 6 times. If you imagine the number 10 6 times, that would give you the answer 60. So 5 times 6 is half of 60, which is 30. So 5 times 6 we can work out as half of 60, which is 30. Let's look at another example. 2 times 9. 9 parts of things is often a hard thing to remember, but if you can remember 10 parts, then you just have to take one of those parts away. The part we're going to take away is a pile of 2 at the end here. So as you can see, we're doing 2 times 9, which is 2 times 10, which is 20. Take away 2 times 1, so that's 1 pile of 2, which is 2. So we can see that 2 times 9 equals 20, take away 2, which is 18. So 2 times 9 is 18, and you can see it here as 2, 4, 6, 8, 10, 12, 14, 16, 18. 20, take away the 2 at the end, gives you 9 piles of 2, which would be 18. Let's look at that again for another problem. 5 times 8. We're looking for piles of 5. I'm going to use coins or money as a picture, way of modelling this. So straight away you're thinking, well, I know that 5 times 10 equals 50. And I'm going to take away 5 times 2. So I'm going to take away 2 piles of 5, which is 10 there. So 50 take away 10 is 40. Much easier than trying to count on your fingers 8 times, but we can check that. 5, 10, 15, 20, 25, 30, 35, 40. 8 piles of 5 is 40. Okay, why don't you pause the video here, try some of these problems, see if you can find out what 2 times 8 would be, what 4 times 9 would be, and what 5 times 9 would be. Remember that the numbers that have been circled are the muchness. The number after the multiplication sign is how many parts. Keep thinking about 10 parts of things to help you work out what you're going to start with. Good luck. Okay, you can also use this distributive law chunking method for larger numbers, like 12 times 3. My first picture here, you can see I've made 12 3 times. So that means the 12 is my muchness, how much have I got? The 3 is how many parts have I got? Then I've chunked that 12 into a pile of 10 and 2, and another pile of 10 and 2, and another pile of 10 and 2. Think coins, it's a very good visual tool. You can even get some coins out and do it for real. Then you can see that if I do 10 pence times 3, I'd have 30 pence. And if I did 2 pence times 3, I'd have 6 pence. Altogether, I'd have the answer 36. 12 times 3 equals 36. Here's another similar example. This time we're doing 15 times table. So 15 times 5. First thing I'm thinking is, in my picture, have I made 15 5 times? Yes, I have. Can I break the 15 into piles? Yep, I can break it into a pile of 10 and 5, and I'll do that 5 times, which means when I write out my grid method, I'm doing 10 times 5, which is 50, and 5 times 5, which is 25. Altogether, I have got 75. So 15 times 5 equals 75. Why don't you pause the video here and try some of these. You can use 10 pences, 2 pence and 5 pence coins to help you do it practically, or try and drawing it using pictures. Ultimately, you want to get to the point where you're able to do it using the grid method, which looks like that. Muchness is what goes down the side. That's how much is in each pile. And along the top is how many piles you've got, your manyness. Again, here's another example. You can do this with even larger numbers. So 25 times 4. Start off with 25 4 times. Then you chunk the 25 into piles of 20, piles of 5, so multiples of 10 and the remainder. This allows you, when you do the grid method, to do 20 times 4 is 80 and 5 times 4 is 20. So altogether I can see 80 and 20 equals 100. So 25 times 4 equals 100. And here's some more problems for you to try. 25 times 9 you can do on the grid method, or alternatively you can try 25 times 10, take away the one pile of 25 to see which method you prefer and which is quicker and more efficient for you. Well done, and good luck with using this law, the distributive law, for chunking, multiplication and ultimately division. I think I'll do one extra one and show you division. Something like 20 divided by 5 means that we're making piles of 5, so I just go 1, 2, 3, 4 piles of 5. So 20, that's my manyness, divided into piles of 5, that's also manyness, equals 4 times, and that's my muchness. So I'm getting this muddled. Let's try again. 20, which is my muchness, divided into piles of 5, that's also muchness, gives me my manyness. How many piles of 5 did I find? I found 1, 2, 3, 4 piles of 5. So the answer to 20 divided by 5 equals 4. If I stick to the 5 times 10 and we look at something like 75 divided by 5, straight away I know I'm looking at the 5 times table, and again using the grid method I've got 75 and I'm wondering about piles of 5. The trick here is to use your 5 times table, so you think 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50 I'm going to put up here because that's 10 piles. This is now 20 piles of 5. I haven't got that much yet, so I know I've got 10 piles and a bit left over. I can actually see the bit that's left over here. So 75 becomes 50 and 25. Well, 5 times 10 is 50 and 5 times 5 is 25. So 75 is now chunked into 10 piles and another 5 piles, which is 15 piles of 5. I'm always looking for piles of 5 when I'm doing those division, and it's divided by 5. Okay, I'm going to stop there.